Hello. This is a talk 3,000% faster file saving with time travel. It's a talk about file formats, mostly targeted at developers, so sorry if you're an artist, but unlike what the title might seem to imply, there's no stats in this talk. I'm not going to bash other programs for being slower or whatever. It's more of a story of how I made things go fast and maybe things that you could put into your program that could also make it go fast, and other future work that's going on, that's happening, that would also be cool to have. If you have any questions and it's something that I can repeat quickly, just interrupt me along the way. I may also take strategic sips of drink if you feel rude about interrupting me. I'm Carsten. You can find me on the internet as Ask Me About Loom on IRC or GitHub or whatever the heck. I developed Drawpile, which is a collaborative drawing program. It means you can draw with other people on the same canvas together online, also animate and other stuff. And the file format that Drawpile used to use primarily was Open Raster Archive, also known as ORA, which is a file format that was invented at the first LGM, I think, 9 years ago. And the ORA file format is basically an XML file describing the structure of the image, like the layers and stuff, and the individual layers are just PNG files inside that zip file. And that's a good format. You can implement that in an afternoon for a parser and a reader. And especially for the things it's supposed to be good for, for one, size is relatively small compared to other file formats. For exchange with other programs, especially open source or free software programs, it's the best format. You lose the least amount of data possible as far as that's concerned. It's good for archival, since you're not tied to any specific program or any specific version of this program. It's just a zip file in XML. So it's for long-term archival, it makes sense, doesn't break. However, as what I'm going to call a work format, it's not that good. If you're working with one program on one file, it has some properties that aren't as nice. For one, it's kind of slow to save, particularly since saving large PNG files for the layers kind of takes a while. It saves whole layers, which is especially a problem for Drawpile because you're on usually very large canvases with a lot of other people. So you have one picture up here, and then other people are drawing across the canvas, and you have another picture down here. There's a lot of blankness in the middle that you pointlessly save in the file, so that wastes time and space. It also saves a merged image, which is primarily for archiving purposes to tell what the image is supposed to look like. It's kind of pointless while you're working on the image. The thumbnail's enough. And it can also cause data loss in a roundabout way. Since there's no separation in Drawpile between the work format and the exchange format, you might open the ORA file in another program, save over it, and lose your data because you didn't make a backup, which is a bit annoying. And so also, the zip format is not particularly good for incremental saving, which might not seem so interesting if you're just saving a raster image canvas, but I'll get to later why that's interesting. So, new format time. I came up with a new format. I called it DPCS. I guess it stands for Drawpile Canvas State or something. I just picked something that didn't seem to have an extension used by anybody else. And the first thing I looked at was pixel storage, since that's the biggest thing in a raster image program and the thing that takes up the most space and the most time. Comparing it with other formats, the ORA file format and the Photoshop document format stores whole layers, like I explained. In comparison to that, the Krita archive format from Krita and XCF from GIMP store tiles. So they separate each layer into same size tiles, and they store those individually. And yeah, that's what Drawpile does internally too, so it just makes sense to do it as well. It has other advantages. For example, the blankness problem I mentioned, when you have images separated by a lot of nothing, you just don't store the tiles in the middle because there's no information there. So you just store the tiles that actually cover the parts of your image. And having a bunch of tiles is much better, faster, easier to parallelize than having large PNG images, especially if your computer has a lot of cores. So you don't get stuck with one of them just spinning around on a huge file while the others are bored. And of course, with a raster image format, you need to look at compression. So while speed is more important over size in a work format, because if you want size, you can just go save an ORA file, you still need to compress it somehow, otherwise it would be ginormous. What we're up against, and we, of course, want lossless compression, since I don't want to open my file and have artifacts everywhere. What we're up against with ORA is deflate compression, also known as gzip, also known as zlib. which if we just use that to compress the tiles, the result is okay. It's a bit faster because of better parallelization. It's a bit smaller because we don't save the blankness, but the difference is not that great. So I looked at some other stuff. For example, WebP, because it has a pretty good lossless mode that has a bunch of different options you can set, was too slow or slower than gzip. I looked at LGMA because that also known as XZ, that also has like bajillion options. Also didn't end up with anything that made me particularly happy with regards to space and size. And then I tried out zstd, or zstandard, which is like really, really, really fast, like orders of magnitude faster than anything else I threw at it. And the size was comparable to other image file formats. It was a bit larger than the Aura file, but like I said, that doesn't matter that much. The speed was really impressively faster. And then somebody called Bondly said, hey, I had this problem before. You know, if you split the channels, so if you save all the blue and then all the red, all the green, all the alpha, and you delta encode it, so instead of encoding the actual colors, you encode the difference between the colors. zstd likes that better for some reason, and the result is smaller. And so, like, okay, I don't really care, the size is okay, but I'll try it anyway. And it actually was, even though I had to split the channels and do that delta encoding, it was like another orders of magnitude faster, because I guess the zstd likes the smaller numbers or something. So I also tried like some other stuff. I was like, okay, maybe it has to do with the size. So what if I reduce the input size further? I tried run length encoding from like TIFF. No, that was just slower and wasn't any smaller. I tried KOI, which is the quite okay image format that supposedly also zstd compresses well. Same thing. I also messed around with zstd's dictionary mode, where you're supposed to be able to like teach zstd the kind of data that you have, and then it gets smaller or faster, I'm not sure. Also didn't make a difference, I guess because zstd already likes the shape of the data when it's delta encoded a lot, so it didn't make a measurable difference. So that's the format I ended up with, zstd plus delta compression. And if your program is using gzip anywhere, and you want to make it go fast, that would be a consideration to make. Maybe you could also use this kind of encoding, and it might make that part go fast. Of course, just saving the layers alone or saving the pixels alone is not enough. We also need like a container format, something that describes the structure of the image. Again, comparing it with other formats, Aura and CRA, the CREA format, save it as a zip file, which is nice because it's like a standard format. If it gets corrupted, you can use standard tools to recover it. In comparison to that, the Photoshop document and GIMP use a custom structure like tagged binary blocks, which are none of the other, have none of those advantages, but whatever, like the obvious solution since quite some years that's better than everything, blows the pants off of everything, is SQLite. You might know SQLite as like that single file database you use when you're doing web dev and you don't want to spin up a Postgres somewhere. But like what it's really good for is this kind of thing, like storing your application data. We have like an application header where you can put a magic number, you can put a version there, you can lock your file from other applications, you can like detect if another application changed your file meanwhile or loaded, all that kind of stuff. They have a lot of documentation on exactly this topic using SQLite as your file format. And it's really fast. Like, I'm pretty sure you'll have a hard time like outspeeding SQLite even for sequential reading or writing. And it's ubiquitous. Your application's probably already using it. Drawpile was already using it for setting storage. It's also durable, so you can, depending on what options you set, you can make sure that stuff doesn't get corrupted. So even if their application crashes, the computer crashes, Windows updates, whatever, the file will not end up halfway written, which is a problem with most other formats. And even if it does get corrupted, they provide a recovery module that you can just stick in your application and tell the user, hey, run this to recover your data, which is pretty neat. I don't think any other format kind of gives you that. And like the name implies, you get like full, quote-unquote, SQL support, so you can store numbers and triggers and whatever, all that kind of stuff. You can also query the data. Why that's interesting when you're just trying to slurp something into memory, going to get to that later again. And it actually does support incremental updates. Since it's a database, you can just edit parts of it. Also getting to that in a moment. So that's what I ended up with. being the format, like the DPCS file format for saving canvases is an SQLite, and the pixel data is with zstd. And I'm very happy with it because it's like 30 times faster than saving an Aura file, 2 times faster than loading it on the low end. Like more pathological files are more like 60 times faster. So there's like what took 2 minutes to save now takes 2 seconds. Or as another comparison, since that might be a bit hard, saving the entire canvas with all the layers in it and the timeline and all that kind of stuff is usually faster than saving the entire canvas as a JPEG, just merged. So I'm pretty happy with that speed up, and I've started using it as soon as it became usable, basically. Right. So I keep going on about like incremental stuff and querying, why that's interesting. This is mostly like future talk, but I think it's really cool, and it's already usable in some other ways, so I have something to show for it. And I would like to see it in other applications because I think it's really neat. Drawpile doesn't just save the canvas. It also has another format that's called deprec, or I guess it's dprec because it's Drawpile recording. What that is a demo file. You might know demo files from like Counter-Strike or Doom or whatever, where like you record gameplay and then you can stick that recorded gameplay back into the game and it plays it back. And that's also what this what the Drawpile demo is. Since Drawpile is a multiplayer drawing program, it has to run over the network, has to send over the network, everything over the network anyway, your entire drawing is a byte stream, and you can just dump a byte stream into a file. And then you can take that byte stream and put it back into Drawpile, play it back, and the result will be the canvas. That's like the final resulting canvas. So like, okay, what's the point of doing that roundabout way when you can just save the canvas itself? Is that quite a lot of stuff falls out of being able to do that. For example, you get continuous autosave. So like, usual autosave mechanism is like periodic autosave. Every 5 minutes you save the canvas. With a demo file, you just save every command as it happens. And if the application crashes, you can play it back up to the point where it crashed. So you get like autosave up to the moment that it went down, which is pretty neat. And it's also like cheaper to execute because you're, instead of like saving the entire canvas all at once in one big chunk that makes the user's computer lag, it just saves like really tiny chunks as you're drawing. But it's not just like autosave. It's also like a time-traveling autosave, because you don't just save the latest version of the image, you save every version leading up to it. So you can go back and like recover something you accidentally deleted or merged or whatever, which in a collaborative environment can happen very easily. So somebody drew something on somebody else's sketch layer or something, you can just recover it. So that came in handy many times. But it's not just time travel. You can also like go back in time and like edit a command. So if you accidentally lined on your sketch layer, you can just retarget those commands to be on the correct layer instead. Okay, there's no UI for this, like you have to do it manually currently, but it's totally possible, and you can like fix mistakes after the fact, which is something that just falls out of the same system you're doing to do autosave. And you can also get time lapses out of it. Like this is stolen from the State of LGM talk. This is just a playback of the demo file that the server had laying around, because the server also has the byte stream laying around, of this picture, this slide being drawn. And you can just, every n seconds, you dump the result into FFmpeg, and you get a time lapse out of it after the fact. And this is actually like a cropped part of that time lapse, because you can just decide on the speed after the fact, which you also get like kind of for free by doing this, by just recording a demo. That's currently a command line tool, also doesn't have pretty UI for it. And another weird thing, it might seem weird, that you can do with this kind of format is time tracking. I already do this like with my regular work, where I like take samples of my what windows I have open, and then after the fact, dump them into an SQLite file. And then after the fact, I can do query, okay, how many minutes did I have this window open? And then sum up all the minutes, and I know what to invoice the client for. When you have like a demo file where all your drawing commands are in there, in a database, and like the times that you made them, you also have this format. So you can actually query your demo and get how much time you spent on the image. And since it's multiplayer, you can also find out how long other people spent on the image, which is kind of neat, which is something you get kind of for free out of the same system that gives you autosave and time travel and time lapses. And I decided, like, okay, the combined format of like demo recording and canvas state saves is going to be DPPR. It's a Drawpile project that's currently in the works. The format like has the infrastructure to support it, but like I said, I need to write UI for it and all that kind of stuff. But it's there and it works, and I'm using it in like a roundabout way, and I would really like other applications to have it because I think this stuff is cool. Right, that's the talk. Thanks for listening. If you have any questions or other things you want to say or mention or ideas or whatever else, now's the time.
Is this on? Okay. Yeah, that was a really cool talk. I'm sure you already know this, but Clip Studio Paint also uses SQLite for saving artwork as well. So it's cool to see Libre format doing it. And I think you mentioned that saving merged and thumbnails are kind of slow. Is that still going to be a thing? Because if we want to have file previews, for example, in KDE, which I'll write, is there still a thumbnail available in these?
There's a thumbnail in there, but there's no full resolution.
Okay, we don't
image.
need that. It might be nice for like Gwenview or something, but like thumbnails are fine like 99% of the time. Okay, cool.
Anyone else?
Did you consider JPEG XL for compression?
No. Does it have a lossless mode?
I'm not familiar enough with the format, but I think it can be quite fast at encoding and decoding, and it's pretty good as an authoring format just because it supports like all kinds of things like spectral images, HDR, whatever.
I could take a look at it. Like I kind of once having reached like ZSTID being like so much faster than anything else I threw it, like by orders of magnitude, I kind of was like, okay, nothing's going to reach that anyway. I'm just going to try making that one better. But it might be worth like using that for the thumbnail, for example, since that's currently JPEG file, I think.
More questions? Okay, then, thank you. Oh, there was one. Oh, shit.
Tricked.
Oh, my God.
Still have time.
Yeah, so demo file, they look really cool. They're very powerful. Don't they like blow up in size over time? Like if I draw on something for like 10 hours, how does it go? How do you manage it?
I mean, we have statistics from the servers. Since the servers use the demo file, the servers are dumb. The servers just, when you connect to a session on Drawpile, the server just loads the demo file and throws it at you.
Yeah.
They're like, an hour of drawing with one person is like 10 megabytes. So it's pretty small, uncompressed. We could throw that into ZSTID as well, it would make it even smaller. So I don't think it's that much of an issue. The way the DPPR format works is, since it combines the snapshot and the canvas state and the demo into one file, you could also like decide, okay, I don't care about earlier data, I'll just truncate it, and then the size problem is solved.
So does the demo file store the state changes of the canvas, so of the pixels, or does it store a chain of events that were generated by the clients, like pen events, for example? How does it work?
It stores drawing commands, basically. So it says like, it has, for example, a command, the protocol like is what's used for like multiplayer. So it's like a network protocol. So it has like, okay, the user started a stroke. Put dabs here with, like brush dabs here on this layer with this configuration. Lift the pen and merge the temporary layer, that kind of stuff. When you paste an image, it does paste the pixels, obviously, but most things are not pixel changes. They're like commands, high-level commands.
Okay, so everybody, oh no, there's another one. You got to be, more active about this.
I was wondering, could it be used in some way as a screen recording tool for other software? Like I'm painting in something else, and
I mean, yeah, like I said, like the time-lapse thing was just the recording dumped into FFmpeg. you can just take what falls out of an FFmpeg and dump it into an RTMP stream, for example, and then you get a stream. So that might even work already. I haven't tried it, but like it's just like raw frames thrown into FFmpeg.